Let me get started. Thank you very much. Um, Thank you for having me, and let me give me the opportunity to share with you how the elements of the total production system eliminate financial, social, and environmental trade-offs. Economic trade-offs, not just operational trade-off, but also economic trade-off, which is going to be really the theme of this presentation. Let's make sure we understand what we talk about here when we talk about an economic trade-off. A trade-off is when we give up something in return for something else. So the examples of that would be maybe on Wall Street, in financial markets, when we choose to have a low return because we're choosing a low risk. Maybe also in medicine, the side effect of a drug, or closest to operation in terms of what we do, changeover cost versus inventory cost. And of course, eliminating those trade-offs requires that we solve problems. So we need to have individual and collective skills, a scientific mind, but also an image of the ideal condition. Understand what good looks like, essentially. And so some trade-off remains because of problem we haven't solved yet, like for instance, living a long time and not getting old. But some other trade-off persist because of problems that we have solved, but yet we have not adopted the solutions yet. And so let's look at how past and current production systems are good, but also creating some trade-offs, and how TPS eliminates those trade-offs and those contradictions in a way that no other production system could do. So before we ever invented a production system designed for efficiency, essentially, we were hunter-gatherers. And we were subjected to nature's notion of efficiency. We could call it a resilient efficiency where only the fittest survived. But sometime around 6000 BC, and I'm not a historian, but sometime around 6000 BC, we began to design production system. And the first one we created is craftsmanship. And so craftsmanship, we could call it nurturing efficiency. We switched from a resilient efficiency to a more nurturing efficiency because it's about acquiring skills and preserving those skills. Of course, the living standard of people improve, but with that comes some trade-offs. And so at the operational level, we can see though that we can customize goods, but that customization conflicts with availability and affordability of products because all the work is manual, it's slow and it's expensive. At the social level, it's a people-focused and rather humanitarian production system, but it is socially, economically rigid because of the guild rules. Essentially, it prevents innovation and also social mobility. And then from the environmental front, it has a low impact on the environment, but of course, we still have famine and scarcity. So we have this production system for about 8,000 years or so. And then because of advance in technology, especially our ability to harvest energy, we see the birth of the mass production system around 1700. And we switch from a nurturing type of efficiency to a more individual efficiency now based on the efficiency of individual assets, especially machines. The living standard of people improved greatly, but it does come with some trade-offs. At the operational level, we see here that we have now availability and affordability of products, but now it conflicts with customization. We are pretty familiar with Henry Ford's famous quote, "You can have any car color you want as long as it's black." So that gives birth to important but also risky financial instruments. And you can think about, 1929, two World War, 2008, and today the debt of nations that exceeds their GDPs. And I'll come back to making that connection again later. At the social level, at the social economic level, now what we see is that machine becomes the most important asset. Labor takes a backseat, and then we have a dehumanization of work. And frankly, this is partially responsible for the geopolitics we find ourselves in today. Think about the Bolshevik Revolution, communism versus capitalism in the Cold War. And then on the environmental front, we have greatly improved the standard of people. Now we have abundance, but that comes with a level of pollution that is unsustainable. So this production system, the second one ever invented after craftsmanship, is mostly the result of technological advancement and somewhat less humanitarian. But sometime around 1950, the Toyota production system is born. And we switch from an individual type of efficiency, individual asset efficiency, to a more total efficiency because Toyota could not afford to finance those kind of trade-offs. They just didn't have the volume to do this. And so they reintroduced a level of craftsmanship into an industrial setting. And we eliminate, as a result of that, some great contradictions. We're able to reconcile a lot of trade-offs that we had before. At the operational level, now we have availability and affordability of products, but also customization. So essentially, we're able to give customer what they want when they want it. At the social level, because Toyota had to solve so many problems at all levels that everybody had to be involved, so we see a rehumanization of work. We increase efficiency, but also restore the dignity of work in the workplace. And then at the environmental level, because Toyota is so focused on eliminating waste, we see the opportunity of continuing to improve economic growth without compromising environmental stewardship. So this production system is mostly the result um, of human principles and therefore more humanitarian in nature. So let's summarize a little bit here. There are three important elements of the Toyota production system, and each of those elements provide financial, social, and environmental innovation. At the financial level, we see that TPS begins to eliminate the operational contradiction that we have between profit and cash flow. And this is captured into the technical element of the Toyota production system and the Toyota economic system book series called Reconciling Financial Results. At the labor relation level, TPS reconciles the creative nature of people, their ability to solve problems, with the mundane requirements of industrial work. And this is captured in the managerial element of the Toyota Economic System book series, reconciling industrial work with human nature. And then the bigger picture at the environmental level, TPS give the opportunity to reconcile economic growth with environmental stewardship because it's based on philosophical principles. And that's captured into the philosophical element of the Toyota production system and in the book series called Reconciling Profit with Sustainable Prosperity. So we can see here that all the three elements of TPS, the philosophical element, the technical element, the managerial elements, are necessary to get the full benefit of those innovations. So at the philosophical level, it's about giving guidance to the technical and managerial element and the kind of complex problem that we have to solve technically and managerially. So the philosophy starts with, we have to be customer focused with our people doing what they do best, essentially using their creativity and their genius to solve problems where the work takes place. But being customer focused is sometimes easy to say, but hard to do. Every company is saying that they are customer focused. But it does come with some requirements. One of them is that we cannot pass defects to the following process. Essentially, what that means is that we have to catch problems early in the process and escalate them very quickly for resolutions before they become big. It also means that the pace of work must be equal to the pace of sale. It means that essentially we can no longer use overproduction to achieve economy of scale. And then at the product level, every product eventually levels back down to being a commodity price. So outside of innovation, the only thing we really control is cost. And then three important notions of efficiency. We have to focus on total efficiency versus individual efficiency because individual efficiency is often in the way of what's good for everybody. We also have to eliminate waste versus force work because forcing work is equal to overproduction and it creates negative externalities and the appearance of efficiency versus creating true efficiency. Essentially, it displaces costs to society and create new one. So with these principles in mind, with its philosophy in mind, let's look at the approach that the technical element of TPS takes. Technically, it's about reconciling financials. It's about eliminating the contradiction in the financials. And Mr. Ono is pretty specific about this. He's basically saying we have to be engineers with a business mind. So let's look at how the business is going to work here or run. There are three important financial statements in a business that we have to pay attention to. The first one of them is the income statement. It essentially states revenue minus cost equals profit. Well, we have to have a profit to be able to reinvest in the company. It's essential. But at the end of the day, having a profit alone is not enough. What we also have to do is to have cash flow to pay bills on time. And when we don't have cash flow, we have to turn to the banking system. And that's when the balance sheet here becomes important. We have to make sure we have enough assets to pay for the liability. But in the total production system, we favor getting cash flow from operation and investment because it's less wasteful. It's the most efficient way to do it. So with the principles in mind and how we run the business in mind, let's look at how the house of TPS, the technical element of TPS, is subordinate to those principles. You're all familiar with the house of TPS, where we have to achieve, on the roof of the house of TPS, the highest quality, the lowest cost, and the shortest lead time. And so from a financial point of view, we need to have quality because quality allows for revenue. Nobody wants to buy a bad product. There's no sales when we don't have quality. We also have to have lowest cost because without controlling costs, we cannot make a profit. And then in the same way, we have to have short lead time because a short lead time allows us to have better cash flow. So we can see here that the goal of TPS is subordinate to the notion of total efficiency, meaning that we cannot just choose one at the expense of the other, which is very different from how the mass production system works. And I like to call the mass production system of trade-offs, where the goal of financial harmony or financial congruency between income statement and statement of cash flow is very difficult to achieve because the mass production system favors reducing costs of individual isolated asset through batch operation, and oftentimes while overproducing to achieve a greater level of economy of scale. So batch production and conveyance is good for profit, but it creates long production lead time. And production lead time has to be supported by inventory, and inventory ties up cash. So we can see here that in the mass production system, there is a structural conflict between the income statement and the statement of cash flow. And it's forcing us to turn to the balance sheet to basically being able to finance the lack of cash flow. But there's more to it. Because we have defects hidden in inventory and very long production lead time, we also have to work to forecast. So to make up for those problems, we have to have excess capacity. But excess capacity costs money. It's expensive. So we have to produce more to pay for it. But in producing more to pay for it, we make more of everything else. Also, we make more unevenness, more waste, more overburden. So what we see is that in the mass production system, instead of simply reducing cost, we also very often displace some cost and create new one. Essentially, we use the banking system to finance the waste. And this is the connection with the debt, okay? And let alone increasing pollution. So the mass production system is not what we want to do. Now we have better knowledge. We have innovated. Toyota has innovated into a better production system. And let's look at what we need to do. In the Toyota production system, technically speaking, we have, for the first time, the possibility of being able to reconcile the financials through the elimination of waste, which means really implementing JIDOKA. And I don't want to oversimplify it here, but JIDOKA is a bit more about improving quality and reducing costs, so maybe a little bit more relevant to the income statement. And then we implement also just in time, which is about flexibility and lead time and more relevant to the system, to the statement of cash flow. But the reality is that neither one works independently. We have to implement continuous flow to make problem visible as opposed to have them hidden in inventory. And at the same time, as we do that, escalate them for resolution through stop and notify so they can be resolved quickly before they become big. But neither one works independently. We really have to also work with standardized work type 1 so that we allow for prompt resolution of problems. And so the result of this is a shorter production lead time. With a shorter production lead time, we can begin to think about the pace of production equals to the pace of sales and essentially implement what we call takt time as a point of reference from which to calculate, reason, and evaluate about the resources we need, people versus machines. And then eventually being able to begin to reconcile the production lead time with the customer lead time, essentially the lead time of producing the preceding process lead time with the following process requirement lead time so that we have a proper amount of material in the system. And then at the highest level, being able to, closer to the ideal, being able to reconcile the rate of pull with the rate of supply by implementing HEJENKA, supported by TAP 2 standardized work, and really achieving a level of flexibility at that moment that can only be realized through human labor. through human flexibility and potentially being able to reconcile the financials. So I don't want to oversimplify it here because every company is different. But the reality is that there is a cause and effect in the elements of TPS that we have to understand. And so this level of technical performance requires that we have all people solving problems. And so this is solving problems under the guidance of what we call true versus apparent efficiency, which means that we must solve problem without displacing cost or creating new ones. And this is the reason that the house of TPS is sitting on a very strong foundation of problem solving. But creating human capability of solving problem efficiently in a company requires that we have a common purpose, expertise, and also teamwork. We need to create a common purpose, an image of the ideal, because to quote the Nobel Prize winner physicist Richard Feynman, science tells us what is, but it doesn't always tell us what ought to be. We need to have expertise also because unless you believe in Joan of Arc story, most of us wake up one morning and we are not capable to solve problems we are not specialized about. So contribution to human progress typically come people who have expertise in their fields. And then teamwork, because in an industrial setting, the work is broken down in chunks of work, and nobody can do the work just by themselves. So creating a common purpose, really motivating toward an ideal, requires that, according to the philosophy of TPS, we need to be aligned with all the elements of TPS. And starting with being customer focused, we need to produce zero defect, on demand, in sequence, 100% value added. And what that means really is that we need to make sure that when the customer is buying something, he's not paying for the waste. But we also have to produce one by one because producing more than one by one or as a customer being forced to buy more than what you need is the illusion of cost reduction. It's not really reducing cost. And when it comes to people of the most important asset philosophy, it's about physical safety, obviously, but also mental safety because we want to make sure that we have the insurance or the assurance of a work well done, and also the assurance that our job will not be replaced by a machine as a result of improvement. And so at the end of the day, it's all about human development. And so with this image of the ideal condition, we can take it and go to a shop floor to understand the initial or current condition. But understanding the shop floor requires that we have expertise. So we also need to work very closely with the shop floor to build expertise at the human level, right? And so understanding the shop floor means and developing individual skills mean truly understanding how the work is done and not abandoning the standard, but using the standard, but going beyond the standard, the contractual relationship with the standard, and begin to develop what we call standardized work. Essentially, a greater understanding of work in regards to time and place. But it also requires that we go beyond understanding the shop floor from a discrete individual machine efficiency and understand how the work flows through a series of processes and how the work is requested, authorized, essentially. So knowledge in those practices of standardized work and material information flow, value stream mapping is very essential for us to be able to build capability on the shop floor and expertise. But aside from expertise, it also requires that we have teamwork. And so if we have a team, for instance, of people, and we have to have teamwork essentially because what I said earlier, in an industrial setting, not one individual can do all the work. So when we have a team of people, maybe like 4 or 5 people with a team leader, depending on the complexity of the work, these people are responsible for meeting output, but also improving toward the ideal, which means that when a problem is noticed, the team member notifies of the problem to the team leader, and the team leader comes and help resolve the problem. So in this environment, we cannot favor solving problems at the expense of output, nor can we favor meeting output at the expense of solving problems. So this conundrum or this paradox is resolved when we are able to make problems that are very small visible and resolve them within a cycle of work. And that does take teamwork. In addition to this, in an industrial setting, the total cycle time of doing something is broken down in chunks of cycle time. And so at the connection points, because we have continuous flow, we must have good teamwork to to allow the work to continue flowing. So with this understanding of the ideal condition and the ability to read the shop floor, then we can begin to grasp the gap between initial condition and target condition. And through scientific problem solving, begin to find the point of cause and the root cause of problems and proceed very scientifically through observation, making an hypothesis and testing that hypothesis. But this role, those activities, is not just the job of a couple of people in the company that are experts, but everybody's job, and to quote Toyota, everybody's job every minute of every day. And it is the job of the team leader to create expertise on the shop floor, to create teamwork, to motivate toward the ideal, and coach toward resolving problems scientifically. So at the end of the day, respect for people means not making the machine the most important asset, but rather reintroducing a level of craftsmanship into this industrial setting by allowing people to become expert, by developing people. And in that way, allowing people to anticipate problem and notify them quickly, or in the worst case condition, if the problem happened, allowing people to solve these problems as a result of their expertise. And in that way, really reconciling the creative nature of people with the mundane requirements of industrial work and restoring the dignity of work that had been jettisoned for the machine during the mass production system era. So let me kind of go beyond a little bit. So to summarize here, big innovation of the total production system, reconciling income with cash flow. Second big innovation of the total production system, restoring the dignity of work in the workplace by reconciling the creative nature of people with the mundane requirements of industrial work. But the benefit of TPS can spill beyond just the operation into the greater aspect of the economy. And so we need to consider at the principal level how TPS can help us at the economical level. Economic growth is fueled by economic activity, investments, but also by improving productivity, essentially efficiency. And efficiency is calculated by looking at the input versus the output. How many resources do I put in and what do I get out of it? And there are two ways to improve efficiency. One way to improve efficiency is to have a constant set of resources, let's say 100 processes, 100 machines, 100 people. And over time, to improve, augment, to produce more out of those resources. So over time, we will produce more. This is a good way to improve efficiency, but the big problem with this is that we often disconnect from the customer and we end up making more than what we need and create negative externalities, debt and pollution, and so on and so forth. The better way to do it, it's not to abandon economy of scale, no problem there, but instead of producing more than what we need, produce what the customer wants, and over time, through the elimination of waste, reduce the resources, and we see it here, reduce the amount of input. And so the conclusion is that if eliminating waste can spur economic growth, then we should consider it as an alternative to just the mass production system and all the negative externalities that comes along with it. But are we implementing the total production system everywhere? And are we teaching it effectively everywhere, even in universities? So what I'd like to leave you with is a bigger conclusion here. The Toyota economic system, which I like to call the Toyota economic system, the benefit spills over the greater aspect of our economy. And what we have to understand here is that it's good for the customer because it reconciles affordability, availability with customization, but it's also good for the firm because for the first time after 8,000 years, we're able to begin to reconcile income and cash flow. It's also good for the worker and good for labor relations because we're restoring a level of dignity in the workplace by using and working with people for what they're best at doing, which is solving problems. And it's good for the environment because we can reconcile ecological stewardship with economic growth. So what we see here that the elements of TPS, they don't work for themselves individually, but they support each other instead. And we really need to look at the total production system not as simply an add-on to the mass production system, but rather a completely new production system with benefits for the operation, but also benefit for the greater aspect of society. And that's the reason I wanted to call this manuscript, these books, a reflection of 30 years of working with TPS, the Toyota economic system. And so thank you for having me, giving me a chance to present my thoughts here. And if we have any questions, I'm happy to take some questions.
Est-ce qu'il y a des... Is there some question? I have one, if nobody is presenting question. I have one. Can you told us, can you tell us more deeper about what you call craftsmanship uh, at
Sure,
scale?
absolutely. Yeah, absolutely. I think that the big transition between the mass production system, which had basically abandoned the workforce and favored the machine, is to begin to reintroduce this notion of skill and expertise in the workplace, but not just randomly, rather by providing people with a very strong framework around what good looks like, and very much of a humanitarian framework. And so it's all about not abandoning the workforce on the shop floor, but rather going to the shop floor and become to be a teacher again. So that's why all my years at Toyota, all my experience at Toyota, my leaders were really teachers, and sometimes tough teachers, but my learning was great. And so it's really about reintroducing a level of mentorship on the shop floor, at the worker level, so they are able to tap into what people have to offer. And the best of what people have to offer is their knowledge, their ability to solve problems, their intelligence, and their flexibility. And so I think that the mass production system was essential to improve the living standard of people. But the reality is that, it took 8,000 years to figure it out. Those are not simple things, okay? We have to realize that and to be humble. But today we know how to do it. And I think adopting it is good for everybody.
There is a question about somebody find that you are talking about kata technique.
Yes, so I mean, there are great books written about kata technique from, I think, Michael Rother and other people. So it's all about basically seeing the supervisor, the leader, not just as somebody who's going to tell you what to do, but somebody who's going to walk you through how to learn what to do, and bring out of you all the capability that comes because you're human, because you're not, the big difference between, animals and people is their ability to think. So in a kata environment, and again, you have to read Mr. Rother's book for the detail of all of that, but it's about going to the shop floor and being purposeful in terms of asking questions and provide the ability of people to reason, not park their brain outside the company and come in the company to be paid for physical labor, pushing boxes, pushing button, moving boxes, but rather for what they have to offer.
So someone is also speaking about Taicho Ono that was in constant fight with the Toyota finance guys uh, because the finance gave the wrong numbers. What do you think of that today?
Well, it's true. It's true that inventory is an asset on the books. I mean, and we're not going to change the standard of accounting for the world. Um, uh, but the world is changing, evolving very quickly. A long time ago, when obsolescence and innovation was not so much of a problem, if you did have some inventory and some material that was stagnating, eventually you could transform that material and sell it. But today, in the world in which we are, there is no question that inventory, because of innovation and inflation, in inventory is a liability, and much more of a liability than an asset. So yes, the financials, the accounting standards are in contradiction with some of the principles of lean and TPS, but that doesn't mean that we have to redefine them. I think that we are smart enough to understand what that is, and understand the benefits of being able to reduce lead time.
Then a question about process improvement. Can you have you an example of the contradiction between individual expertise and teamwork?
Uh, no, I mean, if I have an example of how things work together, that's what they
No,
want to know.
The question is teamwork better than individual expertise?
No, that's neither one nor the other. They have to work together. They're not independent. Again, it's the idea that we cannot just work. There is something that pernicious into our way of thinking, and maybe it's become because of Adam Smith and all those economists, that you have to improve the individual asset. But the reality is that all those come together, support one another, not itself individually. So teamwork is required, individual skills is required together, and it requires we engage people to be able to actually achieve this good congruency. But I think, are we over time now? I'm at 31. So Richard, we may be offline. I'm not sure.
I think you have finished now. It's the time.
Okay. So I think maybe we have to go. Anyway, appreciate you giving me the time. Thank you to the Lean Global Connection for allowing me to share some of my thoughts here. And goodbye now.